So let's take the equation x cubed equals 8. Now obviously 8 equals 2 cubed, so you can rewrite that and you can say that x equals 2, but this isn't actually the full answer if you're looking for all possible solutions of x. So let's try this again, keeping in mind the fundamental theorem of algebra, which states that any function f of x equals x to the n has n solutions when including all real and imaginary solutions. Through some basic algebraic manipulation, we can find that we actually have a difference of 2 cubes here. So by using the factored version of the difference of 2 cubes, we can get this statement equals 0. From there, since the equation is equal to 0, we can use the zero property of multiplication to say that if either of these statements is equal to 0, then it will cancel out whatever the other statement is equal to, and we will get the correct answer here of 0. If we zoom in on this, the algebraic simplification here is really easy. We get that x equals 2, which is the initial answer that we got erroneously the first time, if you'll recall. But we can get our other solutions from this quadratic here. And we can simplify this quadratic using either of these two methods, the quadratic formula or completing the square. So I'm going to explain how to do either of those really quickly. So for the quadratic formula, we start by realizing this is the form of the quadratic formula based on this form of the quadratic. So if we take a look at our quadratic here, we can plug everything in, do some basic simplification. Here we get a negative discriminant, which would normally mean no solutions, but it only means no real solutions because, of course, we can take out I, the imaginary number, which represents the square root of -1, and now we have this. Then you just simplify the radical here, and the simplification of root 12 is 2 root 3. We can factor out the 2 from both of these and cancel it out, or reduce it out, I should say, with the bottom. And we get that this is our answer is -1 plus or minus root 3i, which is broken down into x equals -1 plus root 3i and x equals -1 minus root 3i. But like I said, we can solve this another way without having to use the quadratic formula. So for the second method here, we start by subtracting the 4 here, and then we add 1 to both sides. That's because x squared plus 2x plus 1 is a perfect square, and that obviously takes our -4 to -3. Then we can take the square root of this perfect square, don't forget the plus minus our square root here, and then we have this statement. Then just take the 1 over, and of course take the imaginary number out of the negative radicand, and we're left with the exact same thing that we got out of the quadratic formula, although some people might prefer this method because it doesn't use the quadratic formula. And so in total we're left with 3 solutions, which lines up with the fundamental theorem of algebra, which tells us that for a cubic function, we should get 3 solutions. So yeah, that wasn't as simple as it may have looked at first.